Hello everyone, my name is Wang Hui and my tutors are Shun Dongling and Jia Huanyu. I come from Southwest Jiaotong University. My job title is Investigation of Magnetothermal Evolution of Abnormal Extreme Pulses 1E 2215 and 586. Abnormal extreme pulses 1E 2259 and 586 associated with supernova element CTB 109 is a young and typical magnetic powered magnetor, but has aroused great concern due to its rarely observed anti-glitch. Based on our previous work, we first calculated the electric conductivity of the crust under super high magnetic fields, and then calculated the toroidal magnetic field decay rates and the magnetic energy decay rates by considering the GR effects of the great matter. The effects of the magnetic field on magnetization parameter thermal conductivity was studied. The high thermal emission of matter could be attributed to the dissipation of crossed magnetic fields. The cooling of the abnormal extreme pulses will be simulated by our modified magnetothermal evolution questions in the future. How does the magnetothermal evolution of abnormal extreme pulses 1E 2215Y and 586? Firstly, we have considered the effects of stronger magnetic field on electric conductivity and magnetization parameter. Cross conductivity depends strongly on the temperature and density, with basic orders of magnitude. In this work, we employ realistic conductivity profiles provided by Potikon into the code to produce more reliable magnetic field decay results. The cross-magnetic field of a neutral usually decays at different timescales in the forms of Hall drift and ohmic dissipation. Secondly, we have calculated the magnetic field energy decay rates. Here, we use TMA model to get the decay rate of toroidal magnetic field and the decay rate of toroidal magnetic field. Then the magnetic energy decay rates can be estimated. Thirdly, calculations and observation extreme emission. The observed extreme flux of magnetor is given, and then its persist soft extreme luminosity and the surface thermal temperature are calculated. We take the initial diplomagnetic field as referred in Wagner, which succeeds in explaining the extreme luminosities and surface temperature of young neutrons within the updated magnetothermal evolution model. Firstly, magnetization parameter, thermal conductivity and thermal evolution. Lastly, we have adopted a university questions of straightforward code and creating neutral states with HFB measured to give general expression of magnetism parameters for your pulses. The elementary theory in which the effect collision rate of high calorie with effect mass and number density depends on their velocity gives thermal conductivity when E2259 and 586 will be simulated by our modified magnetothermal evolution questions in the future. Conclusions. We first calculated the electric conductivity of the crust under super high magnetic fields, and then calculated the two radiomagnetic field decay rates and magnetic energy decay rates by considering the effect of abnormal pulses when E2259 and 586. The high thermal emission of magnetar could be attributed to the dissipation of cross-magnetic fields. The effects of strong magnetic fields on magnetization parameters, thermal conductivity, were studied. The cooling of the explore when the 2218 and 586 will be simulated by our modified magnetothermal evolution equations in the future.